Hi, everyone. This is Lowell with another thought about the benefits of studying music, and that is mathematics. Music is fundamentally mathematic, even though it is used to convey emotion, and we understand it as communication. But with high level, really any music, but especially high level created music, there are techniques and tools that are used that use a lot of mathematics. One is in thematic development, um, and there's a type of analysis for a lot of modern classical composition called Schenkerian analysis, and that is where you look through the entire piece to find the same types of patterns of intervals. And in order to understand an interval, I have a little keyboard here. There are 12 notes in an octave, and so here's middle C to an octave above, and the ratio or the interval, the space between the notes is what an interval is called. And so you have minor seconds, minor thirds, major thirds, perfect fourth, augmented fourth, diminished fifth, perfect fifth, minor sixth, major sixth, minor seventh, major seventh, and the perfect octave. And so a sequence of a melody could be to use a minor third and then a perfect fourth, or a sequence of intervals. And so those intervals can be analyzed, and then you see those patterns, whether they be the prime iteration of it, or a inversion of it, or playing it backwards, retrograde, or a retrograde inversion, which is upside down and backwards, or augmentation or diminution. These are all mathematical principles, can be mathematically found, and they use computers to find these types of patterns in thematic development in modern classical composition. And in particular, the technique of serialism, where you take all 12 of those notes and assign a number to it, and where you can see the patterns that are created in that manner. But that's a subject for another day. But that's just one aspect of mathematics. Another aspect is in the overtone series. The overtone series is you have a fundamental, and then that fundamental times itself is the frequency that it represents, which is, let's say that we're talking about 10 hertz or 10 vibrations per second, and then the first note or the first harmonic is times 2. So if it were 10, the times 2, that'd be 20. Then the third note of the harmonic series is times 3. The fourth note, times 4, on up the overtone series indefinitely. And so there you have irrational numbers, you have primary numbers that you're dealing with, and in terms of which of those overtone frequencies are boosted in volume or diminished in volume, causes the type of timbre that a sound has. Like, what is the difference between a piano playing the same note as a clarinet? Why does a clarinet sound like that instrument and the piano sound like a piano? It's because of each one of these overtones being raised in volume or not. A clarinet, I believe, is the odd integers all the way up the overtone series that causes a square wave. And so it's very mathematical acoustics. You get into geometry and trigonometry and algebra when you're dealing with acoustics. There's just even in a simple thing that we start out with our students, we teach what rhythm is, and rhythm is basically fractions. And so you have a whole note, and then you divide the whole note in half, and that's a half note. Then you divide a whole note in fourths, and those are quarter notes. And you keep dividing in half. It's actually rather similar to the frequency spectrum, the subject of frequency, and that's how we derive rhythms. And so mathematics is all over music. And if you want to have a tangible a way of experiencing mathematics. I can't think of any better way than studying music. Hope that helps. I've laid out for you over the last several weeks a bunch of reasons for studying music, and there are many more that I haven't come up with, but that concludes the series of reasons, what we call music soft skills, things that are beneficial for particularly young students to learn, and the application that they can have over a lifetime, even if they stop studying for a while or desire to go back to studying music again. These are things that are foundational to education.